This is an illustration of electromagnetic radiation. It shows you roughly where you go from radio through microwave all the way down to gamma ray. It's pretty easy to see that you have longer wavelengths down at the communication end where radio is, and very short wavelengths down at the gamma ray end. Wavelengths are shown here underneath each respective spectrum. Visible is here with 10 to the minus 6 meters, ultraviolet 10 to the minus 8, etc. Down here is frequency, and we show that with 10 to the 4th, that's cycles per second, or hertz, and that's going to go all the way up to 10 to the 20th for gamma ray frequencies. Frequency itself is given with the symbol nu, and the symbol nu from Greek is frequency, and the symbol lambda is wavelength. And according to the formula, wavelength times frequency equals the speed of light, and that's what c is the speed of light, which is 3 times 10 to the 8th meters per second. And this is going to be the formula we're going to use for the question we're going to answer shortly. Also, the particle view of light takes frequency and multiplies it by Planck's constant. This is Planck's constant. And Planck's constant can be looked up. It's a 6.626 times 10 to the minus 34 joule seconds. And when you use this formula, you will get the energy in joules per single photon with that frequency. So this comes in handy when you want to calculate the exact energy of a single photon. You can then scale that energy up if you need to do more than one photon, such as a mole of photons. So let's take a look at an actual question utilizing that first formula. The radio station KLBJ broadcasts at a frequency of 93.7. On your radio dial, that's what it says, 93.7. That's in megahertz, and this question has already kindly changed that into megahertz for you there per second. We're supposed to determine the length of the waves that correspond to this frequency. So the length here is lambda. This frequency here is given. So we just got to put the two together with our formula. So our formula is C equals lambda nu. We know nu and c, so we're calculating for lambda. Lambda equals c divided by nu. C is equal to 3 times 10 to the 8th meters per second, and we will divide that by 93.7 times 10 to the 6th per second. Notice the per seconds will cancel. We're going to get meters out for our units on lambda, and when you put this into your calculator and multiply it out or divide it out, you get 3.2 meters for your wavelength, and that is exactly where radio waves are supposed to be. They're very long wavelength.